welcome to today's episode of Architecture Wars Monolith, Microservices, or AI First. I'm your host Kavita and I'm thrilled to be joined by two brilliant in tech, Kapil Jain and Tarun Arora. When building a
Hey.
product, it's easy to get caught up in features, funding, or go to market plans. But there's a hidden force that can make or break your success the architecture. It's the backbone that decides how fast you can innovate, how well you can scale, and whether you'll thrive or struggle under pressure. So, have you ever hit a wall because your tech couldn't keep up with your vision? Today, we are diving into three big architectural choices: monoliths, simple, unified, familiar; microservices, flexible, modular, but complex; AI first, the new frontier for intelligent, data driven systems. So, Kapil, let's kick things off with you. Why has choosing the right architecture become such high stakes decision for founders today?
That's a great question, Kavita. Uh, Architecture is a kind of a high-stake decision because of the land tax of the landscape of the current tech space. Because it has changed dramatically from few last years, and and the product cycle are shrinking. We used to have a long cycle for any particular system, which may take years, but nowadays you expect them to be ready in months. So that is why the architecture you choose in a year can make or break the system, and it can make you competitive in 3 years. So take the example of Monolith. They are fantastic for any startup because it's a startup or a small size company. Because everything is in the one code base. Coordination is easy. You can ship every version. But the downside hits when you need to scale your solution. Because monolith architecture can become very rigid, slow you down just when you need to move faster. While there are pros and cons of monolith, microservices tackle this by breaking the system into multiple pieces. You can scale one part. For example, if you want to scale about the payment system, you can do it. While you can keep other parts a kind of a moderate, right? But the flexibility comes with a cost. You need a robust DevOps monitoring and discipline to manage all these kind of a services. It's not a magic bullet. The trades of development simplicity for the operational complexity. Then there is the AI first, which is whole different beast. Think of a building a smart house where sensors, cameras, systems are integrated from the foundation. So it's like, when you're approaching a AI first kind of architecture, that requires pipeline, a model, governance, security, compliances baked from the day one. It's not like that you generally pick something and you generally build everything. During the process, you need it. If you are using AI first kind of a architecture, you need it. You need from the day one. So, too many founders treat AI as an add-on, only face a nightmare uh, uh, in the later stage. So, smart move is to see architecture as a strategic choice, not a just kind of a technical one.
Okay, so that's a powerful analogy, Kapil. Architecture as a foundation of a smart house. Can you share an example of a company that got this wrong or right, and what founders can learn from it?
Sure. Look at the example of Netflix. They embraced microservices early, which let them scale globally and push updates daily. The point is that if they would have choose monolithic, their update would not be too frequent, and they might not scale that well. But they have, at the same time, they have invested heavily in the DevOps to handle the complexity. Contrast what contrast to that, what a startup I worked on was, like they generally follow the monolithic architecture. They move fast, but when they have multiple users on their platform, then they spend million to untangle their code to meet the scale. So the lesson learned is that plan the scale early. Even if you start simple, choose an architecture that matches your growth, not just your current company size.
So that's a stark reminder of how architecture shapes a company's future. Tarun, you work with startups navigating these choices. Do you agree with Kapil that architecture is make or break early on, or is there a case for iterating as you go?
Yeah, I think I definitely agree with that thought. In fact, if you see that the early stage startups, they can benefit from these iterations, what Kapil mentioned. Like initially, they can resort to monoliths because in the initial phases, they most of the development and the product itself is not very, it has not taken shape basically. So it is still in evolving stage, and what is required is that in the initial stages that the basically time to market, that you are able to launch your product uh, at a very quick speed in the market. And if at that point of time, one if the company starts thinking about the microservices architectures, then they will be spending a lot of time in basically decision making, architecting, and a lot of basically brainstorming needs to be done when you go into the microservices architecture. But with monolith, it is very simple. You just start as a big bang. Every service that you can imagine is like a module, and you can just start writing your code, start deploying it within a week. As of, I mean, in today's age, you can actually deploy within a day if you want to, if you are up to that. So you can move to market very fast. So it's I think that's a very valid point, and I agree with that, as Kapil said.
That's a great balance. Tarun, thanks to both of you for setting the stage. And for our listeners, we've got a handy comparison of monoliths, microservices, and AI first architectures. Up next, we'll dive deeper into the pros and cons of monoliths. Now, let's get practical. Tarun, can you walk us through the real world pros and cons of these architectures, not just the textbook stuff? And for our listeners, as you hear this, think about your own projects. Which of these trade offs feel most relevant to where you are right now?
Yeah, look, as I will just continue from where I left. I already explained the benefit of having a monolith architecture, even for any organization who is trying to, even for the larger organizations, like if they are trying something new and they are not very clear about the direction, basically, they can start with a monolith. There is no harm in that. If you just follow the best practices of a modular architecture within your monolith application itself, you can always decompose it into multiple microservices going forward. Okay, it is easier to do. So initially, if you start with monolith, like the debugging is easier, especially because when it's like just one application with which the your user or your basically end other components in the system need to interact with. So your networking becomes very simple in case of a monolithic architecture. So, but the challenge comes when, as Kapil also said, that when you don't, when you start underestimating the basically speed at which you are growing, and you don't envision to move from, you don't plan to move from a monolithic architecture to maybe a microservices architecture. So, uh, problem is that the if you take an example like for a monolith, okay, the code can grow very fast, and you might end up putting a lot of features in that one code base, okay, and some of those features might be very fast moving, but some of them will be very slow moving, okay. So the challenge comes is that and your deployment cycle becomes longer as the code grows because it takes more time to build the code and then deploy it. Okay, that becomes one challenge. Okay. Apart from that, in today's world, in last decade, I would say there are plethora of choices that I mean uh, when it comes to databases and messaging infrastructure, right? So there are many there are more than one database or more than one messaging infrastructures applications tend to use because of the various use cases. Okay, the same application might be using Kafka as well, and it might be using SQS as well from AWS for various reasons. Okay, so if a monolith application is ending up basically connecting to like four or five database infrastructures or messaging infrastructures, that itself becomes a very complex thing to manage going forward. Okay, because even if one of these infrastructures goes bad, basically the whole application can be brought down rather. Okay, so that way these are the some cons of the monolith. But if you compare the same thing with the microservices, as I said, like you can break down your application into multiple services, and each service can work in its own isolated environment. And any basically problem happening with one of the services, it can be controlled. Its cascading effect can be controlled by various design patterns or architectural patterns that are available to us, like circuit breaker pattern and other patterns. So that way you can control the cascading effect in a microservices architecture. But with microservices, again, as we move towards the microservices, we also need to basically upscale our DevOps along with the microservices. If you don't have a good DevOps system which can take care of your containerization and how to deploy the applications as containers in the right orchestration layer. You have to choose the right orchestration layer, whether you want to go to Kubernetes, whether you want to go to maybe ECS, or maybe just the simple virtual machines. So that strategy needs to be well planned and well executed. Otherwise, it becomes a nightmare to run the microservices, especially in production environment. Because once you move into the microservices architecture, it is very easy to grow from 5 to 10 and 10 to 20 microservices, depending upon the domain the size of the application and complexity of the application. So that way it is, these are some cons of microservices. So if you are moving to microservices, you have to plan all these things well in advance and execute them well as well. Finally, the AI first is something which is evolving, and Kapil has also mentioned like a lot of interesting points on that. With AI first, the greatest advantage is that the uh, you can do a lot of things which are uh, not easy to do with the monolith or microservices architecture, especially when it comes to like doing some kind of interactive applications, right? Where you want to build interactive applications like chatbots, which are highly intelligent, which are able to serve customers dynamically. They don't work on set templates basically, but they can use the power of AI to really understand what the user is trying to operate on the application, and how they have to respond to it basically. The predictive analysis is another thing which is very interesting in the AI first approach. And in AI first approach, a very good, you tend to move toward automation a lot rather than just write. So otherwise, what happens is that we use a lot of manual scripts, manual steps in our applications. But in AI first approach, what we tend to tilt towards is that whatever is possible, even the things that are not possible, they have to be automated, right? So you end up building automated workflows, and this helps you prevent a lot of edge case scenarios, and which you can handle by just the organic nature of the AI first approach. But the challenge with AI first approach is that it needs a lot of infrastructure. You need to set up the governance, you need to set up security basically, and the AI models can hallucinate. So you need to do a lot of validation around what the application response will be for various actions. Okay, along with that, over DevOps, you need to basically gear up for ML ops as well, which is a critical part of any AI application. Okay, so yeah, these are some pros and cons of all the three approaches. I hope I have been able to explain it to an extent where it is clear to our users and viewers.
Yes, that was a very clear breakdown, Tarun. I love the analogy that you used. So, Kapil, moving on, you've seen companies navigate these choices. Anything you'd add or challenge here?
Tarun nailed the core trade-off, but I will emphasize that it is not a binary decision, like monolith versus microservices versus AI first. In reality, smart companies evolve through these stages as they grow. For example, if a startup company try to launch an e-commerce platform, right? Then they might start with a monolithic because it's fast, it's simple, perfect for getting some that MVP out the door. You are validating your idea, iterating quickly, keeping the cost low. But once the user base doubles, or you need to add features like real-time inventory tracking or another other kind of a feature, then the monolith become an anchor. Suddenly, small change will take weeks because of everything. Everything is tangled up. Because if you make some changes, you need to test everything. Then there might be some issues. So the release cycles would be a pretty longer. That's when the microservices come in. They will let you break the system into independent pieces. Say one service is for inventory, another service is for payment. Team can work in parallel, and you can scale just one part that needs to be scaled, right? Then then there is one catch. I have seen companies jumping to microservices too early, before their team or infrastructure is ready. Suddenly, they are spending more money in debugging the Kubernetes clusters and networking timeout rather than building features. So it's like moving from a house to a city without learning how to manage traffic. Now AI first is a whole different leap. It's tempting because AI can set you apart. Think personalized product recommendation that drives sales. But without clean data, governance, and monitoring, it's a recipe for disaster. Work with a company that runs an AI first recommendation engine without bias checks. The model started favoring certain product. So, which is not relevant to the customer. The fix, it took them months to fix, months of rework, and then it already hit their reputation. So the smartest approach would be to work in a layer evolution. Start with a monolithic, generally test out the water, then modularize into the microservices as your team and product matures. Then, try AI first. When you think your data is clean, your governance is already there, then that is the approach everyone should follow.
Tarun, quick follow up. What's one practical tip for founders to avoid that rushing too fast trap Kapil described?
Uh, So basically, you need to map your architectures to your growth stage and team skills. I mean, I'm just if so, if like if you're just a 5% team, uh, then maybe it makes sense to stick with the monolithic and focus on product market fit first. But you need to really have that basically roadmap in mind. At what point, basically, you will move away from this monolithic approach. Like when you hit your first uh, maybe 100K users, or when will you start hiring a DevOps engineer, at what stage you will move towards the microservices or AI first approach. So that roadmap and that plan has to be very clearly laid out.
So that's an actionable advice, Tarun. Thanks both of you for unpacking these trade-offs so clearly. Coming up next, we'll explore how to choose the right architecture for your specific product and team. AI is reshaping every facet of technology, from product design to system architecture. Kapil, how is AI changing the way leaders approach building systems?
Kavita, AI doesn't just tweak the system design, it rewrites the rules. Traditional architectures were about delivering stability, predictable features. AI shift the focus of creating the system that learn, adapt, and evolve, like living a organism rather than a fixed machine. This pivot demand a new architectural mindset built on basically three pillars. One is dynamic data pipeline, second is model life cycle management, third is governance and trust. So I'll start with the dynamic data pipeline. AI thrives on the data. Think massive, messy stream of customer interaction, sensor readings, or text. You need a pipeline that ingests the data, clean it, label it, and store it in a both structured and unstructured data at scale, often in a real time. Then comes the model lifecycle management. Unlike static code, AI model drift as data changes. Your architecture must support retraining, A/B testing, and version rollback. Then you lineage the tracking of the to ensure that models stay accurate and reliable. Then the last part is about governance and trust. So AI output must be explainable, decision auditable, and data usage compliant with the regulation such as GDPR, CCPA. This is not optional. It is critical for the user trust and legal accountability. So here is the kicker. AI systems are never finished. Every new data point reshapes them, making your architecture a moving target. It's less about building a feature, it's more about crafting a flexible habitat where intelligence can evolve safely. For example, consider a retail platform using AI for inventory forecasting. The model will learn from the sales data, but a sudden trend like maybe viral product or maybe you can just say it's a like festival season can throw it out. Your architecture needs to retain the model on the fly, test it and deploy update without disrupting the customer experience. I tell founders, don't bolt AI into
Absolutely,
your
Kapil.
product
Too
like
many
a shiny
companies treat
gadget.
AI as a
Design your
threat
architecture
when it's
to embrace
clearly
the
the
constant
backbone of
experimentation.
systems.
Yeah, actually, from my experience, like an AI first approach demands modularity. So microservices are often the best fit, uh, but you can isolate AI driven components, like there could be a recommendation engine or a fraud detection, and
Hello.
iterate rapidly without risking the core product. So if you take an example of maybe a booking platform, wherein basically for a travel company, okay, so you might start as a monolith where everything is like one application, like bookings, payments, maybe product search, uh, recommendations. It could be all one application initially, but over time you can split all these modules into separate services. So recommendation engine can specifically become AI driven platform. Even the search can be AI driven, like you can actually power your search a lot with the AI, wherein the user can be suggested very powerful intelligent suggestions rather than just very basic suggestions, right? And the search itself can become more intelligent depending upon what user is trying to search, okay. And so that ways some of the applications can be microservices can become AI driven, others can remain a traditional microservices kind of an architecture, like payments you don't want to risk too much over there. You build it in a traditional way, you build it robustly with security and performance in mind, basically, and you are done with it. Don't need to overwhelm your architecture with AI where it is not required, okay. And another big shift is the cost itself, basically. So AI systems are very resource hungry. You have to keep that in mind. Okay, they need GPUs to work. Okay, so it's a very heavy cost that one will need to pay. So you have to be very careful that where you are going to use the GPU led AI or where you will not use them. Okay, so for example, a streaming service for a music platform. Okay, they might want to personalize the content. It is a very good use of using a AI over there. Basically, even generating music is something which is being done by the AI these days. Okay, there are people who want to do that. So that is a good use case of AI, okay, where you can bring in rather than over provisioning the entire system. But the real game changer is the cultural and the basically the mental mind shift. Okay, because AI needs a lot of data. Okay, so it requires the people in the organization or people who are working on the project to think in terms of data. So data has to be gathered in a very clean manner, basically, and it has to be uh, uh, Matlab, it's like you cannot afford to miss any data points. Whatever can be captured, you have to capture, basically, because this data can further be used to analyze or debug even the problems at runtime. Okay, it could be a good starting point for making your observability stack a high-powered or advanced version of what we use as of today. Okay, so you need to prioritize the data quality, real-time monitoring, and governance right from the start. Okay. And another example is of a fintech company, okay, where a fintech company can really build a AI-driven fraud detection system. Initially, uh, we worked with one of the fintech companies, and initially they underestimated the data pipeline complexity. Basically, they were just gathering data inputs and bits from various systems without any standardized data pipelines, which led to a lot of inconsistent data and basically not the results that were generated by AI. They were not of good quality. Okay, but once we fixed the data pipelines, we gathered enough data, and we were able to give a lot of context to the AI. They started seeing that the results that were given by the AI, they were of far greater quality, and they were closer to what was really required, basically. So AI it does so. What AI is doing, it is not just reshaping the architecture, but it is also forcing various people in the organization who wear different hats, like data scientists, designers, coders, basically even the product owners, to really think differently. You have to evolve, you have to experiment, and you have to take the accountability also for what you are bringing into the system.
So that's a powerful shift. Now, let's wrap up with hard earned lessons from the field. Tarun, what's one big mistake and one big win you've seen with companies scale their architecture?
Mostly, I have seen the over engineering. Okay, and this is due to the fact that the we engineers, we are very fond of basically experimenting and doing adventures, basically in our architectures. Okay, so rather than taking a ROI driven approach, which is return on your investment, what we are doing, we tend to basically build architectures by thinking that what is the best we can use. Okay, what is the latest and greatest running in the market right now in the tech. Okay, so that is one key mistake which is done by companies. Rather than trying to find the greatest and the best, the architects and the engineers should aim to basically build architectures which are simple and with minimal tech stack requirements. Okay, there should be, and not overloading the application with too many tech stacks. That is one key interesting area. So even I have seen like applications where where the Kubernetes clusters are used, service meshes are used over the observability stack, and it's like you have put each and everything into the Kubernetes cluster without really understanding whether that is really required or not, which makes very difficult to basically manage the Kubernetes clusters on the DevOps side. Okay. So the fix to such operations is that you should start lean. We should focus on delivering value to your users. So your business use case and your uh, how every decision we are making in the architecture, how it is going to contribute to the growth of the business. That is a key mindset that the engineers need to bring in, basically, rather than just thinking like techies over there. Okay, especially for startups. Okay, because startups they don't have too much room in terms of architecture to basically iterate. They cannot just move their architecture from one shape to another shape. Basically, it's very difficult because they are already catching up always on their product features. Okay, that is one thing. On the flip side, the big win is like we have to design for evolution, not for perfection. So smart companies, they would start with pragmatic monolith, as we said, and but bake in modularity and clear domain boundaries. So well-defined interfaces, clean code. So they can help you evolve from a monolith to a much scalable microservices architecture and even the AI first architecture. Okay. So another underrated win is that I mean uh, underrated thing which many companies underrate is the observability. They don't spend too much on observability and they take it very lightly. So observability involves like tracking enough logs, setting up alerts on your applications, on the logs, on the other metrics like your requests per minute, basically your CPU, memory, data usage, network usage. There could be many things on which you can put your logs to understand how your application is behaving. Because if you don't do that, and when the problem strikes, it becomes very difficult to debug it. And if you are not able to basically stabilize your production systems within, let's say, maybe 15 to 20 minutes, then you in today's day and age where basically information spiral, moves like at a lightning speed. You can lose a lot of face value among your customers and in the market as well. So observability is very important so that you are able to react in time and fix your system in time, basically. And in fact, if there is a direct loss of dollars as well, you might lose business immediately if you are not observing your system properly. Yeah, that's it.
Thanks, Tarun. So, Kapil, would you like to add something
Yeah,
to it?
those are great points, Tarun. I would add that architecture is not a technical choice. It's a strategical move for your team, the culture in your company, and the business stage. Too many companies treated it like a puzzle, and puzzle for the engineers, and try to solve it in isolation. That's a big mistake. Right architecture align with your people and the processes. Small, nimble team can crush it with a monolithic architecture with tight communication, and for the larger team, they will thrive on the microservices. If they got it tooling discipline to manage the complexity, that that is uh, that is the reason they can scale it well. So I have seen 10% of a startup company which moves lightning fast with a monolithic, but also seen a 100% company struggling with the microservices because their team were not ready. They don't have the infrastructure in place. They don't have DevOps to manage all these kind of microservices. For the AI companies, stakes are even higher. A bigger mistake is treating AI as an add-on. One company that I advise bolted AI into their legacy system without proper data cleaning. So their model churn out garbage predictions because of the data was inconsistent. Think duplicate customer records and missing fields. So trust in a AI feature is dropped a lot. So contrast to that, I have seen another startup in a health tech domain. They treated the data model and governance as a first class citizen from the start. They build a clean data pipeline, real time feedback loop, explainable AI output combined with the HIPAA. When they launched AI driven diagnostic tool, doctor adopted quickly because the predictions were reliable and transparent. Their user base tripled in a few months. So another key example is anticipating AI scaling like a traditional system, AI workload can spike unpredictably. Think retraining your model during a traffic search. A retail platform that I was handling, this using a serviceless architecture for the AI inferencing layer. When the holiday shopping peaked, their system auto scaled seamlessly, keeping the cost in check and customer happy. So, if I have to boil it down, architecture is a strategy in disguise. The biggest win comes when leaders align with their architecture with their business stage, team maturity, and long term vision. The worst mistake happens when they chase the trend, like adopting to microservices or going for AI first approach without understanding their context.
That's a powerful takeaway. Architecture isn't just about code, it's about building systems that evolve with your team and your goals and your customers' trust. Thank you, Kapil Jain and Tarun Arora, for your brilliant insights. Here's the key takeaway: architecture is the pulse of your product's future. Design with intent, adapt for AI's demands, and align with your team and vision. Don't chase trends, build smart, start lean, and scale wisely. To our listeners, reflect on your systems. Are they ready for evolution? Plan for flexibility and data science first. Thanks for joining us. Until next time, build systems that thrive for tomorrow.
Okay,
Thank you.
bye. Thanks everyone.
Bye.